MCV4U1, Chapter 2, Session 8. In this session, we are going to work on questions assigned in last session, page 90, 91, and 92. The first question is, use the product rule to differentiate each function, simplify your answer. The derivative of f times g, when f and g are functions of x, is f prime g plus g prime f. Therefore, the derivative of h of x is 35x6, the derivative of the first function, times x2 minus 2x, plus derivative of the second function in product in h of x, which is 2x minus 2 times 5x7 plus 1. To simplify it, we distribute 35x6 over x2 minus 2x and 2x minus 2 over 5x plus 7 and collect the like term. H prime of x would be 45x8 plus 80x7 plus 2x minus 2. Part f, x minus 3 over x plus 3, which can be written as x minus 3 times x plus 3 to the power of negative 1. Derivative of x minus 3 is 1. Derivative of x plus 3 to the power of negative 1 is negative 1 times x plus 3 to the power of negative 2 times derivative of inside bracket, which is 1. Therefore, the derivative of the given function would be 1 times x plus 3 to the power of negative 1 plus negative 1 times x plus 3 to the power of negative 2 times x minus 3. We know a to the power of negative m is 1 over m. We use this and we convert the negative exponent to a positive, common denominator, and simplify. Collect the like terms of the numerator. The prime of x would be 6 over x plus 3 to the power of 2. Next question, question number 9. A 75-liter gas tank has a leak. After T hours, the remaining volume V in liters is Vt equals 75 times 1 minus T over 24 to the power of 2 when T is greater or equal than 0, less or equal than 24. Use the product rule to determine how quickly the gas is leaking from the tank when the tank is 60% full of gas. Derivative of a, f to the power of 2 when f is a function of x, is the same as the derivative of a times f times f. A is a constant, it would be a times derivative of first, which is f prime times second, plus derivative of second, which is f prime times first. It will simplify as a f prime f. We're trying to use product rule as it is required in the question. Therefore, the derivative of the function would be 150 times 1 minus t over 24 to the power of 1 times negative 1 over 24. We are looking for rate of change of the function at the time that is 60% full of gas. Notice that V at 0 is 75 and V at 24 is 0. Vt equals 60% of 75. That means T over 24 minus 1 to the power of 2 equals 0.6. We take square root and solve the equation. T would be 5.4 or 42.5. 42.5 is inadmissible, and V prime at 5.4 is negative 4.84 liters per hour. That means the tank is leaking at the rate of 4.84 liters per hours. The negative indicates that it's losing the volume. Next question, question number 10. Determine the slope of the tangent line to h of x equals 2x times x plus 1 to the power of 3 times 2x, x2 plus 2x plus 1 to the power of 2 at x equals negative 2. We're basically looking for h prime of negative 2. The function can be simplified as 2x times x plus 1 to the power of 7. Notice that x2 plus 2x plus 1 is x plus 1 to the power of 4. The derivative of h of x is 2 times x plus 1 to the power of 7 plus 7 times x plus 1 to the power of 6 times 2x. And h prime of negative 2, which is the slope of the tangent line at x equals negative 2, can be easily calculated. Explain how to find the equation of the normal line at x equals negative 2. The point is negative 2 and h of negative 2, and the slope of the tangent line should be reciprocal and times by negative. Negative reciprocal of h prime of negative 1 over 2 is the slope of the normal line. Using slope and point, we can write the equation of the normal line. Question number 11. Determine an expression for derivative of f of x when f of x is g1 times g2 times g3 times gn, the multiplication of n functions. It is generalization to product rule. The derivative of f of x is derivative of first function multiplied by the multiplication of other functions plus derivative of the second function multiplied by multiplication of other functions in f of x plus derivative of the nth function times multiplication of g1 to gn minus 1. Then the next part is asking to find f prime of 0 when f of x is 1 plus x times 1 plus 2x times 1 plus 3x times 1 plus nx. Notice that if we call the components g1, g2 to gn, g1 0 is 1, g2 0 is 1, and gn 0 is 1. Derivative of this function is derivative of 1 plus x, which is 1, times multiplication of other function when x is 0. This gives us 1 times 1 plus derivative of the second function 2 times multiplication of other functions when x is 0, which is 1, plus derivative of the last function n times multiplication of other functions when x is 0, which is also 1. The final answer would be n times n plus 1 divided by 2. Question number 13. Sketch the graph of absolute value of x2 minus 1. We start with the graph of x2 minus 1, which is a parabola upward. The minimum is 0 and negative 1, and the x-intercepts are negative 1 and 1. We know absolute value of x2 minus 1 equals x2 minus 1 when x is smaller than negative 1 or bigger than 1, and negative x2 plus 1 when x is between negative 1 and 1. Therefore, to sketch the graph of absolute value of x2 minus 1, when x is less than negative 1 or bigger than 1, we have the same graph as x2 minus 1. And when x is between 1 and negative 1, we have to pick part of the graph of negative x2 plus 1. Between negative 1 and 1, and more than 1, smaller than negative 1. As we mentioned, f of x is x2 minus 1 when x is less than negative 1 or more than 1. When x is greater or equal than negative 1 and smaller or equal to 1, it is negative x2 plus 1. At 1 and negative 1, we have cost points. Derivative does not exist. The derivative of the function when x is more than 1 is 2x. When x is between 1 and negative 1 is negative 2x. And when it is smaller than negative 1 is 2x. Derivative does not exist at 1 and negative 1. Therefore, the graph of the derivative is part of the graph of y equals 2x when x is smaller than negative 1 or bigger than 1. And if it is between 1 and negative 1, it is negative 2x. The question is asked to find f prime of 0. For f prime of 0, we use negative 2x, which is 0. F prime of 3, we use 2 times x, which is 6. And f prime of negative 2 is negative 4, since when x is smaller than negative 1, derivative is 2x. Last question is asking to show y equals 4x plus 11. The line with the equation of y equals 4x plus 11 is the tangent to the graph of y equals 16 over x2 minus 1. The slope of the given line is 4. Therefore, the first thing we do is finding the point on the graph of the function whose slope is 4. Function can be written as 16x to the power of negative 2 minus 1, minus 0. The function can be written as 16x to the power of negative 2 minus 1. The derivative of the function is minus 32x to the power of 3, negative 3, which is negative 32 over x to the power of 3. If we make it equals to 4, we have 4x3 equals negative 32, x3 equals negative 8. That means x is negative 2. When x is negative 2, y would be 16 over 4 minus 1, which is 3. Therefore, at point P, whose coordinates is negative 2 and 3, the slope of the tangent line is 4. We write the equation of the tangent line using the slope and point, and we'll see y equals 4x plus 11 is actually the equation of the tangent line to the graph of the given function at P. We could simply plug in negative 2 and 3 into the equation of the line and see that line is also passing through P with a slope of 4, therefore it is the tangent line. Thanks for watching.